हेलो, 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 हेलो।
In last class, we started neural network, and based on neural network, the deep learning architectures mainly for healthcare. And among them, the very important CNN, we have had an idea how it extract information from image. It is for image. So others important architectures are time dependent sequential data analysis neural network, that is called recurrent neural network. Another most important, very newly invented, is transformers. It has enormous area of analysis, so we will look into it. And the others are kind of supportive deep learning network for data augmentation, means generating new data sets, or feature extraction by autoencoder. And there are graph neural network also, that is mainly for drug discovery, personalized medicine, for the pharmaceuticals. So with this information, now I will come to the recurrent neural network and the data augmentation. Data augmentation means, for this example, you can see the data, the images are variation, some variation is given to the image, little bit tilted, shifted, in some angle, or it is flipped. So in some way the data is multiplied, the numbers are multiplied when we don't have large amount of data. So this is done by the auto regenerative neural network, that is called GAN. These are little bit of overview what are the possibilities are there. So if we have small amount of data, we should not think it is not possible to do analysis. So there is provision for that. Now that for the recurrent neural network, for every neuron in the neural network, there is some equation, input data is coming, bias is there, that we have seen in the last class. Here a memory is also associated with each neuron, so that it can remember the data input that is current and that is previous. So there is a memory, working memory or long-term memory associated with it. In recurrent neural, the memory is not very large. In long short-term memory, the memory is large. So we can analyze a long-term dependency. So gradually the advancement was done for the recurrent data analysis. So these are the different architecture. So for recurrent network, neural network, what we can do? We can do sequential data analysis, like in ICU or any continuous monitoring system where constant data is coming. It may be heart rate, BP. So when in the OT, there is certain critical level is there. So below that level or above that level, some beep, some alert is come. It is coming. Like it is like that. So in that already known fact, we can think about, if we have continuous data source, the data pattern and how it is degrading or increasing, or what is the pattern of the data variation, that can be learned by a system. And some amount of inferencing, like the critical event detection or prognosis outcome prediction, means hospital readmission, if there is some risk of hospital readmission for a critical decline of vitals, or some critical state alert for some elderly person or some critically ill patient, that they are under continuous monitoring. So this type of analysis can be done by the long short term memory, and with temporal data also, when we have successive follow up data. So one example I want to show, that is on RLVS data. Recently, I have processed data was from patients with acute liver failure who have or mild or moderate or high level of hepatic encephalopathy. The data was from baseline etiology and dynamic clinical parameters, and CT scan was taken. Using this data set, the objective was to find how the patients are critical for having death in near future due to this condition, or what is the emergency level of having liver transplant for the patient. So this was two objective with the data set. So it is a multimodal data. It has static data. When there is only etiology or baseline data, we call it static data. When there is multiple time points, we call it dynamic data. So input data is different types and CT imaging also. And output labels was outcome as mortality 1 and survive 0, and KCH score for the liver transplant liver condition score, that was also high and low. High was 1 and low was 0. It was labeled like this. So it was our output level. It was supervised learning. So data was available for the analysis of that two objective. So there was multiple endpoints, because sometimes we may want to see whether baseline data is good enough, or with some time point variable, clinical variables, that is giving some more information or not. Even with the imaging, if there is CT scan happened, then if imaging can give more advancement in the decision making. So for this, time point data set was analyzed with the static data sets using recurrent neural network, because there was time dependency. Data was not standalone. There was time variant characteristics, and convolutional neural network that we know it is for image. So parallelly, these two models was developed for the endpoint LT urgency scoring and mortality risk prediction scoring. And these two model was then fused. Fused means the prediction score was a weighted average of these two model. Fusion can be at this stage when both prediction probability is available with us, then we can have a weighted average. Or from the beginning, we could have been inputted all the data all together. So it was static in the sense when there was some etiology, pre-conditioning, and some clinical parameters that was only for baseline. But there was some dynamic data, means the blood cultures and other, that is time point. So all the data set can be handled by recurrent neural network, that is time dependent neural network associated with memory. So it can remember what was baseline parameter, what was next time point to there was 4 time point. So successive time point and change in between time point, the delta parameter that we can calculate in our conventional statistics, delta is time point 2 minus time point 1 divided by time point 1, normalized by the baseline, right? So this kind of calculation with all successive variation, that can be handled by neural network internally. Nothing has to be done. Only input will be this Excel sheet. Yes, yes, yes. Okay, okay, okay. For yes, it is not necessary to have CT data. We can only use the clinical data, dynamic clinical data, and we can develop a model. For yes, yes. But if we are try to find out whether image is also important, then the for only those patients who have image as well as clinical data. Good morning, sir. We have started shortly. So when we have imaging data for few cases, we can model differently with only those patients with having all kind of data. So it will be a separate model. So when we are, the starting point is when the data set we are giving, every data set will be present for the cohort. The vector of data, every variable will be same for everyone. If some patient don't have some parameters, we have to drop them actually, because the whole vector should be same. If some value are missing, that is the process is there to handle the missing value. But if the CT scan is missing, it cannot be replaced. So the whole modalities cannot be replaced. Some few variables. Okay. So at this model, when the parallel models are there for prediction of the risk, and that can be then weighted summary can be there, and ultimately the late fusion and mortality risk prediction score was calculated. So with some clinical, this was the priority. Yes, this cutoff value is decided by the no, cutoff value means less than 5.5. This is conventionally used by the algorithm. We can change this also. We have to tell what is the cutoff value to the neural network. Yeah, I have written to understand, sir. The outcome is in the probability from 0 to 1. So we have set this threshold on our own. We can change this threshold. So if we want to have very good sensitivity, then we can reduce or we can increase in that way, where the very specificity is very important for some cases. So in that way, we can change this threshold to have high specificity or high sensitivity. And these were some parameters that was very important for this prediction. Some use cases I have collected from this analysis. The mortality prediction score and LT urgency scores both were low when there was HE grade 4, but KC's score was 2 by 5. It was low KC's, but HE grade was very high. But then also the LT urgency was low because of the KCH score, and the mortality prediction score were also low, some in terms of other clinical factors. So when we see a patient with HE grade 4 and KCH 1, and she expired after 2 days of treatment, in that case, the liver transplant urgency was low, but mortality prediction was very high. So the model correctly predicted. However, the LT score was low because of the KCH score was very low, 1 by 5. So in that, for these are some example how. Okay. So septic shock parameters, I have to check, ma'am. It was only clinical, the bilirubin, platelets, blood cultures only. So in septic shock, like ICU kind of data, where there are the other parameters of vasopressure, the other things. Then it is not only KCH, ma'am, because when KCH score is high also, then also the LT urgency may be low because of the other clinical parameters. So it is not always true. So it is a kind of supportive uh, system to take a call actually. When there are multiple parameters, for example, yes, yeah, it was, sir, 180 around. Exact number I can't recall, 180 around, 70 to 80. Yes, so in terms of sensitivity, specificity, the accuracy table I didn't included here. I can show you after lecture. There was everything. The ROC curve, sensitivity, specificity, everything was calculated. So I didn't include, I just wanted to share this type of example. So this type of analysis can be done in other clinical decision making also. Dr. Harsh. Yes, yes. It is a use case, it is an individual case, but for whole 180 patient, the model was developed. And then model can be used for a single patient with the risk score. So it works in that way. No, it is a representation of some cases, not this 4 type. There are other types also. So now I'm going further. So for example of genomic study, we can have multiple genomic factors, and that can be used for the graph neural network for pharmaceuticals, identification of pathogenic variants, DNA sequencing. So this area is not my expertise. I am just want to share what are the different domains that can be applied for the deep learning based method for any different type of problem solving that is difficult to understand by standard statistical method. For hospital administration, there may be multiple data coming from multiple hospital administration with different set of data structure. The database can be different at different hospital. So that can be also harmonized. And the temporal sequencing of every parameter for every patient, the tracking of one patient across different department, across different data, pathology, clinical, blood test, imaging, everything can be synchronized together and inferencing can be done. The next recommendation, follow-up date can be decided, next recommendation of test can be done, and the risk prediction of the critical patients that are inpatients, that can be also possible. So it can be an integrated system with deep learning intelligence that can provide a inference at once when we input a UHID for a patient. That kind of intelligence can be incorporated into hospital system. So now I'm coming to the very important topic, that is transformers. Whatever we are seeing, we are using ChatGPT, Gemini, or any kind of LLM model, everything is handled by transformers. Why transformers? Because it can handle long data set and complex data set and all type of data set. It can be value, it can be image, video, voice, anything. The point here, you can read these two statements. The needle has a sharp point. They both point to each other. These two sentences means totally different. The word point is different here. The context is different, though the word is same. Transformer, the large language model, understand this context. This is the main essence of large language model. What we type there, it understand the context. Now, how it is done, we will have an overview. The first, it came in 2017. Attention is all you need. This was the article that came with the transformer background, mathematical background and everything. And this was the new beginning of a new era in artificial intelligence, you can say. So with this transformer, now what we can do, a large language model, how they work, we input our text in the prompt. Then this input is not a sentence for transformer that we understand when we do conversation. Transformer understand in different way. It first take every word or subword as a token. And for each and every word or subword, it assigns some numerical vectors. These numerical vectors are the values that tells about the relationship between different words. If there is, you can imagine a word cloud. Lot of word vocabulary are there for a language. So each word have some association with some other word. So that association, if we think about a very large graph, every word can be connected with some edge, means connector, some connection value can be there. So how the word is related to each other, the value will be more. If it is not related, then the value will be less. So patient and doctor is have very good high level of association. So that example where it will come mostly together. But with a patient or doctor or hospital, a mountain river may not come very frequently. So this is the idea, how this tokenization of our input and the embedding is done. The associated value, the mathematical value is associated with each and every word, so that the nearby words can be collected. Because transformer, what it does a prediction of words. When it has collected one word, it will predict the next word. Everything is prediction only here. It will predict the most likely best possible next word. And one by one, this prediction will be done and the output is generated. It is all mathematical. There is no understanding level that we understand by our conversation. It is all mathematical. The embedding, the number of value is in millions, in trillions. That is out of imagination. So that type of calculation is done under this transformer. So how it is complicated, you can imagine. From a million billions of words, it is predicting the best possible next word. So high competition cost is there, training is very complicated, and interpretability is almost nil. We can't understand what is going on inside. But it is a very good human-like conversation it can give. It can scale, means large amount of data it can handle, and state-of-the-art performance, the best performance among all deep learning models. So limitation means high computation cost, very highly complex model. So time taken, very complex, and lot of training data is needed. So when a model is trained, next token means the next word. When it is giving an answer, first word it predict, then second word, the possible best possible second word it predicts. So how contextually it is giving, now when it predicts the sentence, the answer, it predicts multiple instances of answer, and then it identify what is the context in between all the combination of words. So answer 1, answer 2, answer 3, n number of answers are there. Yes, sir, there is one limit. I'll come to that. It is a very good question. I'll go to our next slide, generative AI. So for this, it was the okay, sir. No. So the workflow is like this, and the advantage is that this one I have told. So these were the summary slides, the main architecture, CNN, RNN, LSTM for time-dependent data, and transformer for jack of all trades. So there is DL model limitation is the black box, hallucination. Hallucination means giving a very good stylized answer, but it may be wrong. If because it is bound to give you an answer, it will fabricate something. If you don't have the knowledge, you can't understand. So it is very dangerous if you learn with LLM. Only it can assist you, it can support you for some tedious job to make a very fast, efficient work. But it cannot give you knowledge. It don't have any knowledge. So machine learning is for structural data, tabular data. Deep learning is for image, complicated time-dependent data, or multimodal data. And when to use what? That is a very crucial decision because simplicity is the best thing for a solution. And that judgment is done by the data scientist, the AI engineer. Clinical problem will be given by you. How it will be solved, that is part of the engineering. So it is a multidisciplinary thing. Both should be together hand by hand. So takeaway message, mostly I have discussed already. And now I will go for our fourth lecture. The generative AI and prompt engineering. So with the idea of the transformer, generative AI, what is generative AI we know already. So this answer was given by ChatGPT. Generative AI is typically artificial intelligence that can create new content like text, image, etc. based on pattern it has learned by from existing data. This phrase is very important, learned by existing data. What it have not seen, it don't know. Yes, video also. So Meta AI is there for many things. So there are commonly used generative AI, or mostly we know everything. So in clinical domain, literature research, clinical summary, documentation, research writing, and patient education. These are the very applicable field where LLM can take part. And these fields are not at all risky, where our decision making has to be there. So all this area can be safely used LLM. So what LLM uh, is some little bit concept. So LLM reads token, not words. We write words, but it reads token. It may be word, it may be phrase, it may be subword in its own term. And there are nearly 1,000 token is equal to 750 words. If we type 750 words, mostly it converted more number of token. So tokens are the basic unit of language, words or subword that AI model, the transformer understand and process. LLM short-term memory is during a session, it is around 1 million token. 1 million token is very large amount of data. We really can give a very good length of long paragraph. And it is called the context window, the amount of data that AI can actively consider for the analysis. The rule of thumb is to the low and high temperature setting. This is called temperature. Temperature is not the body temperature. Temperature here, the meaning is how imaginative the LLM will be. Means when we are for asking for a clinical summary or protocol, we should set a low temperature. But when we are generating an image or video, it can be very imaginative. So temperature will be very high. So temperature means how creative LLM output can be. And LML are optimized for plausibly not factual truth. This on the possibility. It is not giving you the truth. So that is very important. So it can hallucinate. And RAG concept is the concept to build some trust. RAG means searching some PubMed index publication or some documentation in some government organization or some standard protocol that LLM can refer and give you answer. So you can direct LLM to refer to those standard information to give you answer and do not hallucinate. You can direct this. So this type of support is also there. So there is two phase. One is training phase, the large data set and the complex training process that we don't see. We are at the phase 2 when we do the application mode runtime processing. We give the token, the temperatures adjustment is done. And the context window setting is done by the model. It is the input layer. Then the data retrieval, the model inferencing is done, means the context development, answer generation, all these things are done. And external trusted data source, that RAG thing is also can be connected with the answer so that it can be more reliable and more optimal. And then the output layer will give the output, the best structured output. And it is checked also, content filtering. It should not give any harmful content, or how the output rendering has to be done. So this output rendering can be also given in our prompt, how we want to have our output. So we'll see how to give the good prompt. So there is some basics in generative AI prompting. Prompting is giving the input. Prompting technique means the blueprint of the input, the structure. And prompt engineering is the iterative process of giving input based on the output. It's a interactive thing. What you are getting as an output, you will see, examine, and you can ask for some modification. So it is an iterative process. So understanding prompting is to understand, you to imagine LLM as a junior resident doctor who has trained with some massive information but do not have clinical knowledge. So what he is telling, you will not believe on it. You have to check it. So prompt is the instruction query that user gives. Output is the AI generated response. The quality relevance of the output depend heavily on the input. So the relationship is what you give, that you get. Thank you. So well-crafted prompt is very important to have a good, structured, reliable output answer. Ambiguous prompt is not have no use actually. So how we will do the prompting? There is some overview structured theory actually it is developed. So there are a lot of LLM models available these days, and it is evolving. It is a very fast evolving area. So what, as the model evolves, what prompting will still be relevant across different LLMs? What is the basic structure? What we must know. So we should be able to answer these two questions. What should I say in the prompt to make LLM provide the desired output? How should I present the prompt so that LLM can efficiently understand it? Because it is not a human, it is just a mathematical model. And if you are giving very structured, good prompt, then only it can parse it and understand it. You have to remember it. How we conversation, okay, please come. That does not mean anything. There has to be some context. Please come to the class to have a discussion, this kind of thing. Where, who, when, what, everything has to be there. So the basic concept is role, style, or tone. That has to be defined, means how LLM will act for you. The goal, what is your goal? What you want to know? The context, what is the background or relevant knowledge, area knowledge? The instruction, exactly what you want step by step to do by the LLM. The structure, how you are formulating the instruction, that has to be in structured way. It should not be haphazard. And how you want to have the output also, you can tell the structure also. So input, instruction will be in structured way. Output, how you want, that can be also told, and you can show some example also, so that it will give exactly what you want. So role means what the voice or persona should LLM take on its response. You, for example, you can write, you are a certified expert academician in hepatology. So LLM now act as an expert academician in hepatology. if you want a bedtime story, you can tell LLM, act as a granny with some grandchildren for a telling a nighttime bedtime story will have some animals as a characters, and it will not be more than 100 words. So in that way, everything you can specify. So goal is the information you need to ask LLM while successfully complete a task and given the desired output. So you can write in this way: give elaborated PubMed indexed literature review in chronic liver disease of last 20 years. See, it is very specific. What we type in Google prompt, literature review in CLD. So it will give lot of articles. It is not like that. You can be very specific. So last 20 years, PubMed index only in chronic liver disease. So what background information should you give to LLM so that it can better understand the norms behind the task? So you can, here the norms will be, this document is for my dissertation. So it will understand the applicability of the search and how it will form the result. And you can tell the limit your response within 100 words. You can add also, can tell what can be more in output structure. The reference should be in AMA style or APA style. You can give a table also for. Yes, ma'am. It is for a fast extraction of information, but it has to be checked. That is the main thing. Whatever it is giving, it may not be correct. Yes. AI, where is check? So there, I have, by knowing it, it may be a controversial topic, because for student, it is very easy, very fast thing to do. And if there is possibility and way to do thing fast in efficient way, it is good to do. But you should not skip the step of learning and checking things. If there is very bad, very illiterate kind of things is there in terms of clinical sector, then you are at your stake. God can only save you. So so in this time, the publication houses also there is one clause: do you have used any generative AI or LM model for research writing? So for text writing or improving the language, it is okay. You cannot add your clinical or intellectual input. You can generate your intellectual input by LLM. You can merely edit, because fast language may not be English for everyone. So that type of support is okay. But we should understand, all of us are adult, and we should understand where to stop. So there is way to expedite the efficient way, smart way to do things, but we should not be so foolish to take everything, whatever garbage it is giving. So prompt techniques, how to say? How to say is breaking the complex word into steps, and this improves the clarity, depth, and consistency for the model to understand. So step 1, define the problem. Step 2, propose solution. Step 3, summarize the impact. So in this way, you can structureize the problem and your output structure also. So there is some markdown language. It is XML markdown language. It has some header, close, and means some like introduction, methodology, research, result, and discussion. It will also have some headers. Headers is start with this triangle bracket, and it is ended by the slash of the same word. So it is a markdown language. It is very comfortable to understand by the transformer. But this is not necessary to understand. It is for very complex query prompt. But for our purpose, the step-by-step English written prompt is good enough. And how you can show the example? So zero shot prompting means what it is, you ask the AI to do something without showing any example. It is called on your own you give anything. But if you want to have a specific output, then you can tell the format or style need to be shown, or you can test more complex or creative, that if the task is more complex. So the example, by example you can tell how you want the output. So this is an example of good and bad prompt. Please read. The bad prompt is what is the differential diagnosis for a patient with high ALT and AST and a yellow tint to their eyes. This much is prompt. Compared to the other one, act as a senior transplant hepatologist, review the case with all the parameters, history of alcohol use disorder, provide a 3-column differential diagnosis table detailing diagnosis supporting feature from this text and immediate red flags. If data is insufficient to rule out acute liver failure, ask me clarifying question fast. So this is an example of giving a scenario for examination. When we have to give some present case scenario for a resident doctor for exam, so this type of case scenarios can be developed, or questions also can be developed. So these academics and literature research, their LLM can help us to make things fast. So it is a systematic curation of text input, context aware, accurate, safe, and context aware response it gives most possibly, and exercise in clinical communication, translating medical intent into computational guardrail. Why this guardrail? Because clinical sector has many high stake areas. So, and what it is not a software. No programming is needed. It is, of course, a black box. You don't know how it is giving the answer. And it is not a Google search. It needs specific structured instruction to give you the output. So for prompt engineering, the CLEAR framework is the established theoretical framework that is followed. CLEAR is for the first letter of these 5 words: concise, logical, explicit, adaptive, and reflective. So the words tells about what is the characteristics. And all these I have already discussed. So it is an iterative process. Understand the need. Craft prompt means when you have anything in your hand that you want to ask, means solved by LLM, that has to be first understand the problem. Then you have to craft the prompt. Prompt will give you some answer. Then refine the prompt and evaluate the AI output and iterate the process. Means after evaluation, you can change the prompt also. You can direct LLM to give some modification in the answer according to your need. So it is a iterative process. Whoever have already used, they know. So one caution, it's very powerful, but it can be very fatal. So finance mistake, banking serious concern, damage AI hallucination, how the damage of hallucination can do, or AI getting smarter, less reliable. All these are different news in past few years. So there are lot of concern also. So in healthcare, it is more important to be very cautious. So hallucination is one problem. So in prompt, you can write, if you do not know the guideline, say unknown. Or data privacy, we should not upload our clinical patient data just like that, the Excel sheet in the LLM to have our analysis. For thesis, it is very attractive to use the LLM, but our UHRD should not be uploaded. Even the data should not be uploaded in that way, the whole Excel sheet, because whatever you are uploading in the internet, it is gone. It is open everywhere now. It is accessible. So automation bias means over relying on relying on an elegant but flawed AI output. So it is always you should verify. And demographic bias. When we are applying LLM, it may be trained with some demography data, may not be applicable for the other type of race or different geographical area. So some clinically useful LLM models are Google Med Palm, clinical question, decision support, complex medical reasoning. Different LLMs are there, but it is still in the research area. We should not use it in practice till now. So key takeaway is the rule of thumb is role, goal, context, instruction. So we have to define everything properly. The clear protocol, concise, logical, explicit, adaptive, and reflective. This is the process how we do prompting, and it's a tool. It can support you, but it cannot replace our knowledge. So there is some prompting exercise. I am not going to discuss now. So it is for different type of scenario. I have generated it using the Gemini, and the result is also given by the Gemini. I have just used Gemini to create the prompt also and to have the answer also by the Gemini. To just have an example how in clinical scenario, some questions, some case presentation can be hypothetically done. So documentation and note stripping, like SOP structure. If we have a free text in SOP structure, how it will structure the whole information. So this type of application is very useful in hospital administration and exam and research purposes. So when I'll share the slide, please go through it if you are interested. Thank you. LLM models are open source. We can use the model for our own purpose locally, of course. For hospital type scenario, where data security is very concerned. So here we can use locally. So Hugging Face is the very commonly used portal where most of the LLM and deep learning models are available open source. We can download that and we can use that for different purposes. So that we will download the training model. The training part, all the weights means in the neural network, the weights coefficient in that terms, everything is fixed. It is freezed. We will train on our data set, and it will give it is a supervised thing. So how it is giving the result, it can be performance can be evaluated. So in locally we can train in our data set and we can use it. This is the way how we can use it. Yes. So one thing is, when you have the domain knowledge, you will understand the result is not as you want. So one thing is, it may be towards the answer, may not be properly what you want. So then you have to change the prompt. You have to restructure it. Yes. And yes. But most of the time, it gives some output plausibly correctly towards in the direction of correctness. May not be fully correct, but sometimes we need to give more structured form to have our good answer actually. So it is most of the time it depends upon how we are asking. So you can so you cannot ask, ma'am, one thing, you cannot ask a novel question that it don't know. You can ask a existing information that this globally it is known. If you want to ask something that is no, inferencing means that is a knowledge level thing, then it will be problematic. Means that type of information it don't know, means some very philosophical question also you can, means there are a lot of different directions. But if you are scientific innovation kind of thing, if you want to ask, it cannot do, because innovation is something that is really invented. It has don't know the idea, the data. So what is published, invented, present in this world, it has that idea. What is not available till now, you cannot ask that. Agentic, no, agentic AI is agent that can use LLM. Agentic AI, you can tell a programming that can do multiple tasks automatically. Just that's all. Yes, yes. So, automatically it can access LLM model. Automatically it can access different type of data in internet. Agentic AI it's a kind of automated programming. Programming have one input, one output, or agentic AI can have multiple steps. It can give multiple step-by-step output, take multiple in between inputs also. So total workflow can be framed by a agentic AI program. Paid, yes, better than, of course, better than the free. Yes, yes, but yes. Yes, so it has large amount of database already associated with this. LML is more stronger compared to Google actually. Yes, ma'am. But for now, the freely available LLM is good enough for our regular work. Not very specialized. We are not doing very specialized kind of thing. So yes, very complicated kind of work, then it has to be upgraded. But so personally, what I feel, sir, here I want to add, as a AI engineer, this AI is a two-sided sword. If it is good, if it can be very bad at the same time. We are not using our brain. Still, yes, sir. Still, I prefer to use PPT because I can use my brain, but still I have some images also that is created because, for example, that whole layout of the different models. So, so this type of slide, if I want to create by my own, it will take days. And maybe it will not be so nice. So for this type of things, it is good, but it may be one or two slide in my lecture. Other thing, what I want to make understand, it is understandable only when I write the things. so that I will be convinced to say that things, because these words are not mine. Yes. No, ma'am, there is 4 more lectures. But this heavy part is over. Now that are lighter. 4. Now today I'll send 2 more. So lecture 3 and 4 is covered till now. And one